So next one is 16-bit division. In 8086 assembly language, we can do the word by byte. I mean, you can divide 16-bit number with 8-bit number. Okay, so let us go with the program. The first line is always assume CS code, then comma DS data. So we are assuming the names for logical segments as code and data. Then let us start writing the data segment, data space segment. Now you need to consider the variables for number 1 and number 2, and for the result number 3, and these two are, one is word I am considering for this 16-bit, and other is I am considering as byte. Alright, the dividend and divisor. So n1 is dividend and n2 is divisor. For this you can consider any number. I am considering 4343h, and this one is 67h, and we don't know the result. The result size is word, always you will be getting 16-bit, and the result as of now is initialized with question mark. And why you require this word size to store the result? Because when you divide the 16-bit with 8-bit, the possibility of quotient is 8-bit, and the remainder is also a 8-bit, the maximum possibility I am considering. So for that reason, to represent the result of this division operation, you need to represent this quotient and this remainder, right? Okay, so to load these two values, the result size must be a word. Then data and s, data and s. Let me rub this. So now we need to start the code segment, code space segment, and let us use a label to indicate the start of the program, start colon. Now you can use these two lines whenever you are using the data segment in the code segment, ODS comma AX. Now you need to load these two numbers, 1 to AX and other to BL. Why I am using BL? Because N2 is a byte, right? You require a 8-bit register, that is BL. And what will happen here? AX will be loaded with N1, BL will be loaded with N2, which is equal to 4343h, 67h, and this AX is dividend and BL is divisor, right? So now you can use the instruction of division, the 8086 instruction for division, that is div. Now here also, as multiplication instruction, here also you have to represent only the BL, the second operand, the source operand. What about this AX? That AX is implicit operand for this div. You have to remember, for MUL and for div, the AX is implicit operand. That means you need not to represent, or you need not to include, or you need not to write that AX whenever this div and multiplication instructions are being used. So you can write simply div BL. When this instruction is executed, div BL, what will happen? The AX is divided with BL, you will be getting some quotient and you will be getting some remainder. And after this instruction, the AL will be loaded with quotient and AH will be loaded with remainder, right? So that means now simply you can load the result variable with AX. Now to know the exact memory location of this N3, you can use this load effective address of N3 to SA to know the exact location number of this N3. Now you can stop this with the debug breakpoint int 3h. Then you can end the code logical segment, code end s. Then you can end the program which is started with the label start, right? So this division you can do with calc, whatever the quotient and whatever the remainder, those will be loaded with AX in this fashion.